Hello everyone. Good afternoon. Can you hear my voice?
Yes.
Okay, thank you. Welcome to the International Expert Sharing Meeting. Today we will discuss about automation and intelligent control in equipment manufacturing. Before we start our event, let me introduce myself. My name is Rifda from Go Study, and I will be your Master of Ceremony as well as the moderator for today's session. So, without further ado, let me read our flow of activity today. The first, I will introduce its activity introduction. I will introduce the background of the activity as well as introduction of experts to all of you. And then the second, we will have opening remark from representative from Simiotad. And then we will have expert presentation session 1, followed by Q&A session 1, and then expert presentation session 2, followed by Q&A session 2, and lastly, we will have group photo and closing. So guys, please look forward for our webinar today. I hope today you will gain a lot of new perspectives and insights from all the speakers. So our background introduction, our activity purpose, the International Expert Sharing Meeting aims to strengthen academic and professional exchange between education experts across ASEAN and ASEAN countries and China by providing a shared platform for dialogue. The series encourages diverse cross-disciplinary interaction, supports regional knowledge exchange, and foster deeper collaboration on emerging educational and industry trends. As for the future outlook, our event, the International Expert Sharing Meeting, will be held every month, so stay tuned to our webinar, with each session featuring a distinct theme. Topics will span various fields such as education, business, and engineering, providing a diverse and enriching experience for scholars. And has joined with us today our amazing 5 experts from 5 different institutes, which are from University of Surabaya, Indonesia, Chachoengsao University, Thailand, Pham Nhat University, Vietnam, Polytechnic Manufacturer Bandung, Indonesia, and lastly, we also have speaker from University Putra Malaysia, Malaysia. So let me introduce our first speaker, which is Dr. Ivan Kristianto Singgi, STMT PhD. He is the head of System Engineering Laboratory and assistant professor at Department of Industrial Engineering, University of Surabaya, or mostly known as Ubaya, Indonesia. And he is also the head of Supply Chain Modeling and Analytics Group at Indonesian Institute of Supply Chain and Logistics at Institute Supply Chain and Logistics Indonesia, or ISLI. And then he gained his master and PhD holder in Industrial Engineering Department. And lastly, he is a trainer in coding camp at Department of Industrial Engineering at University of Surabaya or Ubaya, Indonesia. Um, Before we move to the second speaker, Dr. Ivan, you join with me. Can you say hi to all the participants?
Good afternoon, everyone. Thank you for attending. Nice to meet you.
Nice to meet you, Dr. Ivan. Looking forward for your presentation. Okay, we will move for the next speaker who will be presenting. The next speaker will be Dr. Parinda Panthet. She is the program chair of the Bachelor's Degree in Electrical Technology, Institute of Vocational Education, Central Region 3, Thailand. And then she also a lecturer in Electrical Power Department at Chachoengsao Technical College with extensive experience in vocational and technical education. And she gained her PhD in Learning, Innovation, and Technology at King Mongkut's University of Technology, Thonburi, Thailand. And lastly, she also an award-winning researcher in vocational education and electrical technology learning innovation. I think Dr. Parinda has also joined us. Dr. Parinda, can you say hi to the audience?
Hello, everyone. Good morning and good afternoon, everyone. Thank you for having me.
Yeah, thank you. Looking forward for your presentation, Miss. Okay. Next, we will have the third speaker, which is from Vietnam, Mr. Nguyen Tan Nan. As you can see here, he is a technology and digital leader with 15 plus years of experience in AI, automation, and digital transformation across multinational organizations in Asia, Europe, and the United States. He also a digital human health led MSD Vietnam from 2024 until now, up at the present. And he also former Coster IT head and country DPO at Schneider Electric Vietnam in Cambodia, and previously held leadership roles at Intel, Bosch, and Procter and Gamble, delivering Industry 4.0 programs and large-scale digital supply chain innovations. I think I have already seen Mr. Nan. Mr. Nan, can you say hi to the audience?
Good afternoon, everyone. Thanks for having me here, and we're looking forward to an interesting session together.
Okay, thank you so much, Dr. Nan. Looking forward for your presentation. And then we will move for the next speaker, the fourth, which is Professor Dr. Insinyur Yuliadi Erdani. He is a professor and senior lecturer at Polytechnic Manufaktur Bandung, or known as Polman Bandung, Indonesia. And then he also a PhD receiver in information engineering from University of Duisburg-Essen. And then he specialized in information engineering, automation, and guided vehicle systems, and also chairman of the Academic Senate at Polytechnic Manufaktur Bandung, or Polman Bandung. And he also, until now, he's an active researcher, author, and keynote speaker in vocational and engineering education. Professor Yuli, can you say hi to the participants?
Okay, hi everybody. Good afternoon. Nice to meet you. Thank you very
Nice to
much.
meet you. Looking forward for your presentation. Okay, lastly, we have our speaker. Wait a minute. Okay, the last will be, sorry, Dr. Tinagaran Perumal. He is, as you can see, he has a lot of amazing achievements here. He is an associate professor at Faculty of Computer Science and Information Technology at University Putra Malaysia, and head Department of Computer Science at University Putra Malaysia since 2024 until now, and co-secretary at Service Management at AUN Digital Transformation, or ASEAN University Network. Also chairman, National Committee in ISO, or IEC TC 16 Internet of Things and Digital Twin, Department of Standards Malaysia, Ministry of Investment, Trade and Industry, or MITI Malaysia, and also chair IEE Consumer Technology Society Malaysia chapter. Dr. Tinagaran, have you joined us? Dr. Tinagaran? Oh, he hasn't joined us, but he will join us with us shortly. So without further ado, I have already introduced our amazing speakers to all of you, our experts who will be delivering their presentations today. And now let's let's enter the opening remark from Semiotet. I have already seen Mr. Fomara. Mr. Fomara, the time and screen is yours. This will be delivered by Mr. Fomara. He is the head of technical education and training division of Semiotet. Mr. Fomara. I think he had a technical issue. Let's wait for a while.
Can you hear me?
Yes, I can. Yes, I can hear you, but your video, yeah, now it's clear. Okay. Okay, sir, I think you're still muted.
Good afternoon. Can you hear me?
Yes, I can hear you very well.
Thank you very much. Good afternoon, honorable speakers, educators, and participants. Very warm greeting from Semiotet, Cambodia. I hope everyone is wonderful. It's my great pleasure to deliver today's opening remarks on behalf of Dr. Song Hyang Ai, Semiotet Center Director. Welcome to the third International Expert Sharing Meeting on Automation and Intelligent Control in Equipment and Manufacturing. Thank you very much for taking the time to join this event today. This event brings together experts, educators, researchers, and professionals from across the region who share a common interest in advancing automation, intelligent systems, and modern equipment manufacturing. In today's evolving industrial lives, technologies such as automation, artificial intelligence, smart control systems are transforming the way industry design, produce, and manage equipment. These innovations are not only improving efficiency and precision, but also reshaping the future of manufacturing and workforce development. Today's meeting serves as an important platform for knowledge exchange and regional collaborations. Through this session, participants will have the opportunity to learn from leading experts, gain insights into emerging trends, and discuss how intelligent technologies can be applied in education, industry, and research. We are particularly honored to have 5 distinguished speakers from different institutions across ASEAN who will be sharing their valuable expertise with us today, who are Dr. Ivan Krisyanto Singgi of Indonesia, Mr. Nguyen Thanh Nan of Vietnam, Ms. Parinda Panpech from Thailand, and Professor Dr. Ing Yuliadi Erdani of Indonesia, and Dr. Thingaran Harumal from Malaysia. We truly appreciate the time and commitment of all our speakers who have kindly agreed to share their knowledge and experiences with us. I am confident that their expertise sharing in their presentation will provide valuable professional insights and inspire meaningful discussion among participants. To all participants joining us today, this is an opportunity to your active participation will make this session more dynamic and I would like to who have worked together to make this event possible from different countries.
Mr. Fomara. Okay,
Can you?
thank you.
I think I finished my speech.
Okay.
Back to
Yes,
you.
sir.
Thank you
I think
very
it's
much.
lagging in my device. Okay, thank you so much, Mr. Fomara, for your kind opening remark. I hope this could boost everyone here to enthusiastically join the session. Thank you so much, sir. Okay, let's start. I think we can start the main session today, which is the expert presentation session. So guys, if you have questions to the speakers about their presentation, please feel free to send your question in the chat box. I will help you read them during Q&A. So let's start with the first speaker. So for presentation session 1, let me read it once again. Our speaker for the first session will be Dr. Ivan Kristianto Singgi from University of Surabaya, Indonesia, and then Dr. Parinda Panpech from Chachoengsao Technical College, Thailand, and then Mr. Nguyen Thanh Nan from Phang Ngoan University, Vietnam. And then the first speaker is Dr. Ivan Kristianto Singgi from University of Surabaya, Indonesia. He will be delivering a topic with the title Dynamic Problem Importance Identification Using Machine Learning in Production Systems. Dr. Ivan, are you ready?
Yes, I'm ready.
Okay, Dr. Ivan, I would like to remind you that you will have 15 minutes for the presentation, and you can start your screen sharing. The time screen is yours.
Okay, thank you very much. Okay, I'll try to share the screen first. Can you see my screen well?
Now, yes, I can see it.
Okay. Yes, thank you very much, everyone, especially the committee and respected speakers, also all attendees. I am really grateful to be here because I believe that I can learn a lot from all of you as well. So please let me share some of my research that starts from my curiosity in applying machine learning to several of my research topics. I will talk about dynamic problem importance identification using machine learning in production systems. So actually, I'm from the industrial engineering department, and I deal more about the scheduling production systems and then optimizing logistics, route, something like that. So hopefully we can get some interesting discussion today. So you can find my information here, my curriculum vitae, email, and GitHub. Anytime you want to discuss with me, you're welcome to just contact me. So I was basically, after studying until my master degree in Indonesia, then I moved to Korea. I did some research there, including collaboration with companies. So I am learning to understand how our research topics can be useful for companies, and even until now, I'm still learning. Yeah, I already talked about this one. So I also work on some optimization methods, also some coding. So I also try to combine the machine learning techniques with the optimization part as well. So because today I will talk about one of my paper that I presented that I published with one of my undergraduate student. It is actually talking about how to optimize the logistics in container terminals. So if you are curious about the basics, then you can try to take a look on these references. Actually, I have sent the committee my presentation files, so you can request them, or if necessary, I can also share it in the chat. Please just let me know. So basically, a very short introduction. We already know about this actually. So we are talking about the Industry 4.0. There are many data available. So basically, what things that was impossible before now becomes possible. Basically, we can do almost everything as long as we can try to understand the benefit, the opportunities, knowing what people need. So that will be a great opportunity for us. For myself, I started to learn about machine learning in 2021, and I think there are many opportunities here. So we talk about how to collect the data using many sensors, and then how to utilize the data. And even I'm very curious to learn about digital twin today, but actually, yeah, that is also one of the main framework that we can use in Industry 4.0. Gathering the data and then utilizing the data in real-time fashion. So one question that I want to ask all of you is, suppose that we have congested traffic. You're riding a motorcycle or riding your car, and then suppose that you need to wait longer than usual, like 3 hours in the same spot. Then let's think about what will be the main problem. Is the problem related to the traffic light control, the duration is not good, or is the problem in flowing the cars? So sometimes if you know some area is already having too many cars, then we should not flow the cars there, right? Or maybe there are uh, some problems with the car in some areas, so we need to resolve that first. What I want to say is, when we do not have any data, it becomes difficult for us to understand the main problem. Some people, when they think about the congestion, they will just think that let's just solve the traffic light problem. But eventually, when we check the facts, that is not the real problem. So what I want to discuss today with all of you is how we can collect all data. Basically, everything happens around us in the topic that we are discussing. And then based on that information, we find which is the real problem. After we know the real problem, then we start to solve that problem first. And hopefully that will give a better result for our whole system. So today I will talk about the case study in the container terminal logistics. So please let me give some insights about many sub-problems, many cases that we can find in this area. So you see here, we can talk about the design of the container placement. We can talk about how we stack the containers. We can talk about the schedule of the crane. We can talk about the berth allocation, means that where the ship should stop before doing the unloading and loading of the containers. And even we can do some truck movement scheduling. So there are many things that we need to do. When I started to think about machine learning for this kind of logistic problem, I was thinking that, did people really find out which problem is more important before solving them? If we read many papers, many researchers try to say that, for example, scheduling is the most important one because it will affect this and that, and then they propose the scheduling method. But I am actually not that easily convinced, because I think that it is not that easy. We should see the whole data. After that, we conclude whether the scheduling is the most important one. If not, maybe the scheduling has no problem, but they wait too long for the for some other processing. Then we need to resolve that part first. So that leads me to start the study in machine learning. This is some examples. If we have this is the automated container terminal that I studied in Busan, Korea before. So suppose that we have some automated vehicles moving in this area. So we need to determine the direction of the movement. If it is two-way, then there will be many congestion. If it is one way, then it will be easier to flow, but the time will be longer. And we can also think about the schedule of the cranes moving the containers from the stacking yard here to the ship. We can think about the schedules there. We can think about the placement of the ships in the terminal. So there are many things to think about. This is the example. We try to calculate the shortest movement time. This is one case. The other case here is, in practice, usually we have a very easy way to put the containers on the ship. Suppose that we have, if it is on the top of the ship, then we follow this sequence 1, 2, 3, like that. But there are other studies that I did with my supervisor before. We can try to consider many places at once. So we can try to find many sequence for loading the containers on the ship. And we also consider the movement of the cranes, like the physics. So even this problem itself is already complicated, but the problem still remains. Is this more important than the routing part or not? That will be the remaining question for us. This is another case in the automated container terminal. Then the vehicles, if they enter a certain rail area, then they cannot change the direction easily. So there are some other methods to make sure that we do not put the wrong vehicle, so there will be no problem in the movement, something like that. Again, is this the most important part in the whole system or not? So that is one example for the container terminal logistics. Let's go to another part that we try to learn deeper about the manufacturing case. So as I told you, I'm working on the scheduling part. So if we see here, we have 3 stations. We are talking about the semiconductor processing. So we have 3 stations here, and then we have 6 operation. This is operation 1 in this area, then going to this place, operation 2 going to this place, operation 3, and then going back to this machine, operation 4, going back to this machine, operation 5, and then eventually 6, and then finish. So you can see that the problem is very complex. If you see the real semiconductor factory, then it will move non-stop. Basically, it will be very busy. Then now we need to know, we have many optimization decision. For example, we need to schedule the machines. If we have many jobs arriving in one station we have 2 machines, in some station we only have 1 machine. So suppose that we have station 1, we can select machine A or B. Then we have a problem to select which machine will we use. And then if we select machine A, for example, we have many other parts waiting for the operation. We need to determine which part need to be processed first, the scheduling part. So there will be many cases, and then also some machine can process the part one by one, but some machine we need to combine them into batch, and then we process together. If we make the batch good, then it will be easier. There will be no waiting time. But if we wait for a long time to find some other parts to combine because the type is same or something like that, then it will take some time. So there are also batching decision which is complicated. So the question will be, which one is the most important? We try to find a very easy way, an initial study. We try to use machine learning. So we have the classification and regression. Basically, in our case, we have a target for 1 week. We need to produce 74 overlots, 74 products, something like that. Then if our scheduling thing is good, if our allocation thing is good, how we manage the production is good, then we will have 74 or more products at the end of the week. If we have less than that, then something is wrong. Then we can learn from the data. If we have this kind of data, then the result will be good. We will have many output. But if the input is like this, then the result will be bad. And we try to learn from the data. And I didn't show the details, but if you are interested, you can take a look on this paper here. So it's already published, and we have a detailed list of the features. There are a lot of them. Basically, what we want to say is, after we know which part is more important, for example, if machine E is more important than machine C, based on the machine learning results, then when we schedule the machine, we should focus on machine E first. Don't do the machine C, because the output of the system is more influenced by machine E, something like that, simply like that. So after having this kind of research, then we can determine the most important sub problem to solve, to optimize, and then we work on that. Okay, that is the introduction. So now let's go to the detail of our presentation. So this is the paper that we presented in a conference and then also published in a special issue of the journal as well. So basically, in the container scheduling, in the container terminal, we have many processes, and we want to find which one is the most important one using machine learning. So this is my partner in this research, Aditya Saputra. So most optimization studies, as I told you before, they just say that this problem is important. Let's work on the scheduling. Let's ignore the other part. But in this case, we want to run the whole simulation, and then we collect all data, and then after that we find which one is the most important. That is what we want to do. And then this is the illustration of what I have just told you actually. And then we try to combine the operation research and our AI as well together. So if we think about the dynamic situation, you can imagine that now we have all data. Basically, for example, if we use a navigation application in our phone, then basically they can record our movement, they know where we are going, something like that, and they can use that information for making other decisions, right? They can update the information, they can think about how to set the traffic lights or other thing like that. But basically data are everywhere. So if you think every second, how many new data do we have? There are a lot of data. We are not talking about only the data where we are, but we are talking about the data everywhere that is related with the problem that we are talking about. So you can imagine that we have the data, new data every second, but we need to make decision all time, right? If we make the decision more often, then we will get better result. For example, in the traffic light, if we know some part have the waiting time too long, then we need to make the green light longer for that area. So if we can observe the behavior of the system again and again continuously, then we can always make the better result. So that is what I want to propose when we talk about the dynamic. We collect everything. Anytime we need to make decision, we make decision. So the prediction part should be very fast. And then how we do the optimization, how we decide the decision should also be fast as well. So that is the summary of this framework. So here we are talking about the simple flow. So this is the container terminal. The trucks are coming inside and then putting the containers into the storage yard. After that, when the ship comes, then the internal trucks here will go to the storage yard, get the container, and then bring it to the ship. And then after that, give it to the ship. So we have 3 machines somehow. the yard area here, the yard cranes, and then the truck here, and then last is the quay crane area. So we can think about it as a flow shop scheduling problem. If we are from industrial engineering, I believe that you heard about this. So these are the input parameters that we use for the machine learning. As I told you, we are trying to collect all data that we can have. So is this all data that we have? Of course not. You can add much more. So we have the processing time for each machine, and then we also have the container that we need to process. We have, for example, 10 containers. We have those kind of information, and also we have the scheduling rules that we use in each machine. For example, so in the internal truck, the easiest way is if we have many containers, then they will just choose the first one available, so they will not wait too long. But sometimes we can try to find the closest one from the truck to minimize the movement time. So there are many scheduling rules. So we try to observe whether the scheduling rule is more important, or the processing time is more important, or other thing. So yes, this is the basic thing about the scheduling process actually. So one yard crane can only process one container at one time, can only lift one container at one time. It also applies for the internal truck and quay crane. And then this is the sequence. So we must do the processing at the yard crane, and then after that give it to the truck, and then give it to the quay crane. That should be the sequence. And then we are trying to minimize the make span. Make span is if we have 10 containers, the last completion time will be the make span. So if the make span is short, then we finish the process very fast. And then we make the simulator using Excel, which is quite simple. And then this is the input. So the processing time have the mean
Dr.
value
Irfan?
and standard deviation. Yes, sure.
Dr. Irfan, I'm really sorry, but your time
It's
is
okay.
actually up. Can you wrap up your presentation? Maybe
Sure.
for 1 minute?
Sorry for that. Thank you.
Yeah, okay.
Yeah, so we have this kind of information and the rule as well. And then finally, when we try to see the result, we conclude, we test several machine learning models. I will skip this one. And then finally, we find out that the scheduling is more important than the processing time, which makes sense. But the most important one is, you see, we have quay crane, truck, and yard crane. We conclude that scheduling the quay crane and truck is more important than scheduling the Y crane. That's why what I want to say is, if we directly schedule the yard crane without thinking about the real case, then it doesn't make sense. Our schedule will not help the whole system eventually. So that is the simple one that we have, and I believe that you can also apply this to many cases in your life. Hopefully it will give some insight, and thank you very much sorry for the extended time. Thank you.
It is okay. Thank you so much, Dr. Irfan, for your presentation. I hope all the participants already notes what they want to ask to you to confirm if any is not clear enough. Okay, without further ado, let's move to the next speaker, which is okay. Our next speaker will be Dr. Parinda Panpet from Chachoengsao Technical College, Thailand. She will be deliver a topic title, which is From Intelligent Control to Competency-Driven Innovation, Advancing Smart Manufacturing and Sustainable Community Development in Thailand's EEC. Dr. Parinda, are you ready?
Yes, I'm ready.
Okay.
Can
the
you
time is
share my slide, Lita?
yes. Okay, I will share it.
Okay.
Okay, okay. Okay. Please, your time and screen is yours, Dr. Parinda.
Okay, good morning and good afternoon, everyone. First of all, it is great honor and pleasure for me to participate in the International Expert Sharing section. I would like to express my sincere appreciation to the organizer for providing valuable platform for knowledge exchange and collaboration from different countries. My name is Dr. Belinda Panpet, and I am a chair of bachelor degree program in the Electrical Technology at Chachoengsao Technical College under Institute of Vocational Education Central Region 3 in Thailand. My academic and professional work focusing on vocational education competency-based learning and the learning innovation in electrical technology education. Today, I would like to share our experience in connecting intelligent control technology, competency-based education, and collaborative learning ecosystem to support smart manufacturing and sustainable community development in Thailand Eastern Economic Corridor, or we call EEC. I hope this presentation will provide useful insight into how vocational education can contribute to both industrial development and sustainable society progress. And let's start for the next slide, please. Okay, I would like to share how intelligent control and technology can be connected with competency development, innovative learning system, and sustainable community development within Thailand Eastern Economic Corridor, or we call EEC. The EEC is the one of the Thailand's most important economic zone and designed to promote advanced industry, smart manufacturing, and technology-driven development. Many industries in the region adopted automation technology, intelligent control system, and digital manufacturing platform. However, technological transformation alone cannot ensure sustainable industry growth. What truly determines success in the ability to develop a competent workforce capable of designing, operating, and innovating within this advanced technological environment. This is where education become critical in Thailand. So, Chatham South Technical College, under Institute of Vocational Education Central Region 3, we aim to bridge the gap between industry needs, educational development, and community engagement. So our approach focusing on develop competency-driven, innovative, where education not only prepares students for employment, but also equip them to contribute in industry innovation and sustainable community development. This presentation, how to intelligent control technology, competency-based education, and collaborative partnership can work together to support smart manufacturing and sustainable development in EEC in Thailand. Next slide, please. So about the intelligent machine require intelligent control. Modern manufacturing system is increasing evolved into what we call smart manufacturing environment. In this environment, machines are no longer simple mechanical devices. Instead, they are intelligent systems capable of sensing, processing, and responding to operate condition in the real time. Key technology include industrial automation system, programmable logic controller, we call PLC, and smart sensor or IoT integration or data-driven monitoring system. This technology allow industry to optimize production processes and improve operation efficiency and ensure greater reliability and safety in manufacturing operation. But however, the effectiveness of this intelligent machine depends on intelligent control system that govern their operation. Therefore, development of the expertise in the electrical technology is my program about the automation and the internal control system become a critical foundation for modern in the system. And in EEC Thailand, we are transforming towards smart manufacturing and demand for professional with strong knowledge. And in this program and in this area continue to grow. Next slide, please. Okay, while advanced technology are still the successful implementation depend on people, not just industry, but also focusing on people. In other words, intelligence require competency, engineer and technology. In stakeholder consistently emphasize the need of the graduate who possess a combination of technical expertise and analytical thinking and the professional responsibility. We call it a high order thinking skill. And to address these needs, the electrical technology program at Chachoengsao Technical College SMILE program has been developed the principle of the outcome-based education we call OBE. And OBE is focusing on clearly defined learning outcomes that ensure graduates acquire a measurable competency aligned with the industry requirement. So instead of the focusing on just teaching need, teaching watch, teach OBE exercise want to students have to able to demonstrate and perform as well. This approach allow us to design curriculum structure, develop not only theoretical knowledge, but also practical skill as well, and also attitude as well, innovative capability, and ethical responsibility. Next slide, please. So one of the strengths of the vocational education in Thailand and Chachoengsao Technical College is the development of lifelong learning pathway. Our educational system provides multiple levels in the learning progression, including vocational certificates and high vocational certificate, we call diploma, and the bachelor degree in the electrical technology is a continued process. The structure allow learning to continue as one that electrical and in engineering education and the professional competency throughout this career and support flexible learning. We have the credit bank and the credit emulation and credit transfer system. Students can build their educational pathway according their professional development goal as well. Okay, next slide, please. About the public-private partnership, we call PPP e-learning ecosystem. Another key element of the educational approach to STONG, we call PPP. This model connected around educational institution with industrial enterprise and community stakeholder. Through this partnership, learner extend beyond to the classroom and become integrated with real industry and the social context. One important mechanism is the work integrated learning, where students gain hand-on activity, hand-on experience by working directly with the industrial partner. During the process, students can approach and explore to real production system, real engineering challenges, and real workforce environment. And in addition, we also provide competency development program that support upskill, reskill, or new skill. Students can adapt to emerging technology and involve industrial needs. This collaborate ensure that educational program remain closely aligned with the industry requirement. Okay, next slide. Beyond developing of the technical competency, we also emphasize about the development of innovation capability as well. In our program, students complete innovative project, and if we call like thesis in the undergraduate, right? After student have to the last year student have to do innovation project, can offer the final project. This project we will collaboration with the industrial partner and local enterprise and community organization. And the objective is not only academic learning, but also we have to practical problem solving as well. Students can encourage to develop technological solution that address real industry challenges or support local community development. For example, this project may involve designing about the automation system, improving about the energy efficiency in the industrial processes, or developing technological solution for small enterprise and community business. For at the moment, I am the Geneva as well to take my student participate in the international invention competition. So my goal is encourage them to develop something that innovative and can be benefit to community, and their machine or their devices that they invent can represent a technology with the potential to compete the international stage as well. Okay, next slide. So green tea with for sustainable development. Finally, an important dimension of the modern vocational education is sustainability. This is where the concept green tea with becomes highly relevant, and green tea with integrated environmental responsibility in sustainable energy practice into technical education. Students learn not only how to design and operate technology, but also how do so in way of the promote energy efficiency and environmental protection and responsible resource management, and through integration, competency-based education, public-private partnership (PPP), innovative project in the last slide, and the green tea with awareness, vocational education can contribute significantly to sustainable industry transformation. Next slide, please. By connecting technology, education, industry, and society, we can build an integrated ecosystem that support manufacturing, green innovation, and sustainable development in EEC and beyond. Technology transform industry, but education transform people, and empower people transform community. Thank you for your attention.
Okay, thank you so much, Dr. Parinda. I think this quote is very inspirational. Technology transform industries, but education transform people, and empower people transform communities. So technology has no meaning if the education we didn't raise the quality of the education.
Yes.
So thank you so much, Dr.
Thank you.
Parinda. Yeah. Okay, for all the participants, I hope you have understood what Ms. Parinda said before. But if you guys have any question, please feel free to send your questions in the chat box. I will read them during Q&A. Okay, let's move for the third speaker. I see Mr. Nan already opened his camera. So our third speaker is Mr. Nguyen Thanh Nan. He is from Pham Nhat University, Vietnam. And today we will be discussing about smart robots and executive briefing with case studies. So Dr. Nan, the time screen is yours.
All right, thanks, Rita. Let me start sharing my screen. And let me know if am I audible, loud and clear?
Yes, loud and clear, and I also see your PPT as well.
All right. Good afternoon, everyone. Thanks for joining today. My name is Nguyễn Thành Nhân from Văn Lang University in Vietnam. And today my topic is about smart robot. And I would like to share some talk and observation on a topic that increasingly shaping many industry on how intelligent combine with robot and create value for a business. So I hope to share this session in more like reflection and insightful discussion, especially for all of us as professional scholar, educator who interested in how AI and robotic are evolving together. Okay, to keep it straightforward, we will look at three areas. The first of all is the state of the art is what makes the robot smart today. Secondly, the business impact and the value, where we will briefing explore some real world example from a case study. And finally, a future outlook, we look at how robotic adoption may evolve in the next few years. Okay, when we speak about smart robot today, we're really talking about the intersection between artificial intelligence and the physical world. From a strategic perspective, a smart robot can be seen as a AI-enhanced physical access that support digital transformation and operational efficiency, right? Unlike the traditional machines that simply repeat program tasks, these smart robots are able to adapt to changing environment, learn from our experience and data, and more importantly, it can increasingly collaborate with a human worker safely and securely. And we also do see one interesting concept here is called polyfunctional robot, which means that the robot can perform the task even beyond their original programming. Instead of being designed of a single function, those robots can be reconfigured through reinforced learning and demonstration, or even apply some AI model to enhance the intellectual properties. So those flexibility is what makes robotic much more attractive as a long-term investment for any kind of organization. And I would like to share a couple of examples from my practical experience. So there's the company called Intel, like Dr. Evan also mentioned in his presentation. I worked there 14 years ago, and they established indicator called man-machine ratio, MMR. So exactly they want to measure that how many human labor can operate at a certain number of machines. Of course, is a measure to quantify how competitive advantage of one factory compared to the other one. So because it's also related to the cost per unit of the manufacturing expand, and that is the indicator we work every year to make sure that we keep lowering down the ratio. And the second example I have is from the company Procter & Gamble. I also worked there back around 10 years. They have indicator called touch, right? So one touch means that I need to go to computer to log in, to key in information. So it's gonna introduce a lot of waste of effort. So how the question is how we can reduce the number of touches to make sure that we come to the ideal state that is gonna be future automated, right? It's a fully automated manufacturing. So every year we also take the same exercise to see that where is the baseline of the touch that we have today, and what is the automation, AI, and technology can have us to reduce the number of touches. So that's also the real industrial case that I would like to share. All right. So now what you can see here is when we think about robotic is to distinguish between two environments for AI to operating in. The first one on the left-hand side, we see is the digital AI, which operate entirely in a digital world, right? So things like recommendation engine, like we have with Netflix or Spotify, or not the bot, like chatbot, service bot, or not the software bot that we built, or even the demand forecasting system. So all of that belong to the digital AI space, right? Vice versa, we have the second one on the right-hand side, we call it a physical AI. So where intelligence interact directly with the real world. So here we have some example like industrial robot, right? We have the robot arm using in the factory. We have autonomous machines like AGV or ASIS using across many MNC and wearable device, so even become very popular during the COVID times. So what makes robotic particularly challenging is AI must work within the physical constraint. Right now we have AI embedded into the robot, the physical robot. So we have the constraint from the hardware, the power of the sensor, the energy consumption, and even the safety requirements. Right? So that is why many robotic systems today is heavily relies on the intelligence, allowing decision to be made locally, even without the network connectivities. And if we observe how robotic is evolving today, we can roughly group the application into 3 domains. Right? The first one, we call it human augmentation. So here, robot have human to perform some tasks that are dangerous, repetitive, or physical demanding, such as inspection. And a lot of inspection can be replaced. Exoskeletons or medical robot. That's some of the good example. The second domain is the social interaction, is include the robot used in education, workplaces, or even the personal environment. And the third domain is smart automation, where robot improve the operational excellence in areas such as logistics, agriculture, and construction. One interesting observation is that robots are increasingly working alongside with humans rather than replacing them. So we may know about the history of the people resist of the industrialization, right? Some worker in UK they put a damage into the machine because they think that machine can replace the human, right? So it's the old story already, but now with the technology keep evolving, we do see that risk lessen and really robot and human can harmonize to work together in certain scenario. All right, to make it more even more concrete, let's briefly look at some few live real example. We have company Cargill for agriculture, US company. They apply deploy the Boston Dynamics Spot robot in its protein processing facilities, right? So the robot is perform remote inspection and monitor equipment condition for predictive maintenance, for example. This improve the worker safety and allow the company to detect the potential issue earlier through the concept predictive maintenance, right? Another example on the right-hand side is from retailer John Lewis from UK, which implemented robotic storage and retrieval system in its warehouse. And some of the amazing results included they have to improve picking accuracy and with higher throughput and reduce the labor cost. So these cases show that robotic is already delivering very practical operational benefit for those enterprise. Right, and the third case study here from Mary Washington Healthcare in healthcare domain. There's the collaborative robot called Mousy, were introduced to handle the non-patient facing tasks such as delivering supply, transporting some lab example from room to room. So by doing so, it's returned more than 14,000 hours of time for the nurses and allowing them to focus more on the patient care. So it's really improved operation. And last but not least, in manufacturing domain, BMW also been piloting the humanoid robot to perform repetitive and ergonomical demanding tasks on production line. These robots are not replacing human, but rather complement the human being. So the ideas of human and robot collaboration is likely to become increasingly more common in futures. All right. There's another interesting insight from many robotic deployment is that the biggest value does not necessarily come from the most impressive tool. Humanoid robots often attract attention because they demonstrate the technical capabilities, but in practice, organizations often achieve more value by focusing on specific use cases where robot can be deployed quickly and efficiently. Another important factor is the emerging of the generative AI interfaces, whereby we have more user interface and we can interact directly and more user-friendly for the adopter. So these allow human to communicate with robot using natural language or even very simple instruction make the robot easier to deploy and reconfigure by even the non-tech people. In many ways, the challenge today is not only the technology itself, but rather than how to deploy it effectively in the real operations. Okay, so how the future look like ahead of us? Robotic adoption is expected to expand, so that no doubt. We do see some prediction here on the diagram that it's gonna be keep gradually expand across many sectors, right? Until even 2030 and beyond. Some applications are already become common today, particularly in logistics. So we hear some sharing already, inspection and delivery system, right? So in coming years, we may see increasingly adoptions in areas such as agriculture, healthcare, and construction. So even now, for example, in Vietnam, we do see more and more robots in those areas, in construction site, or even in hospital or in the farm that can apply for those company here. So for organization consider robotic, the key recommendation is to focus on high impact use case. So take calculation on the ROI and the value return rather than implementing without any lead objective. At the same time, it's important to carefully manage the ethical and security risks. Robot become more autonomous. So with that, I would like to conclude that the real question right now for the organization, for our business, that how we can deploy robotic responsibly and meaningfully to create the value for society. And I strongly believe that it's going to be nurturing more and more by all of us right now for the better futures. Thank you so much for your time today, and I truly appreciate the opportunity to share those thoughts with you and looking forward to the discussion. Thank you.
Okay, thank you so much, Mr. Nan. It was such an insightful presentation. And actually, I have questions that I want to ask you, but let's move to the Q&A session first. Okay, I have seen a lot of questions being sent here in the chat box before. Let me screen share this one. So to all participants, you are still welcome to ask any questions, or if you want to do discussions, please feel free to send it in the chat box. I will help you read them. I have seen questions from Keira. This is for Dr. Parinda. So Dr. Parinda, Keira wanted to ask about, she said, what an insightful presentation, Dr. Parinda. But I would like to ask, how can universities ensure that the graduates possess not only technical expertise, but also innovation and entrepreneurial skills?
Okay, first of all, we have to provide the curriculum that can be provided subject which have to needs in the student enterprise and innovation, such as like IoT, automation, and maybe if the old curriculum is not proper about the technology enterprise. So about the skill, we have to promote students to like upskill or reskill, something like that, or the short curriculum and the short seminar for upskill the student as well. Because maybe in the curriculum can be not effect about the skill. Yeah, but maybe like have to provide more skill for the seminar or the program, especially needs of the enterprise. Yes.
Oh, okay, so the university needs to make some kind of curriculum that could train the student skills. Is that right, Dr. Parinda?
Yeah. Yes.
Thank you so much, Dr. Parinda. Kira, answer your question. Okay, let's move to the next question. This is actually my personal question for Dr. Ivan. Dr. Ivan, I would like to ask, how does machine learning help the companies identify and prioritize the most critical problems in production system compared to the traditional ones?
Yeah, thank you very much, Ms. Rifta, for your question. So basically, company have limited money, right? So if you know the right problem, you make the right decisions, then you can basically save your fund, and then you can get more profit. Because when you talk about running a company, actually you can just imagine the company have already operating for example 30 years. Then basically you have all information you need. You know when the company improved, when the company profit is decreased, and then if you know all information behind that, then you can finally find which one is the most important one for your company. So you can imagine then the problem will be, what kind of data should I collect? It will be somehow easy, but somehow difficult, but also easy. Why? Because everyone working in the company, from the low level until the manager, they have that kind of insight. What you need is just to make those insight into the data. Then if you say that maybe this is the problem ABC, then you can just try to collect those data, and then we can see the improvement in this kind of performance result 1 to 3. Then you can compare those two and then find the relationship, as easy as that. The only question is, sometimes starting new will be difficult, but once you try a very simple one and you find the advantage, then you will be, I wouldn't say addicted, but you will be excited to find much more relationship, and it will be much more easier. Why? I didn't talk into the coding part, but many people can even learn easily. And then if we do not talk about ChatGPT or other AI methods yet, they can even make the code for you as long as you can check the results. I think that's my answer.
Okay, I think that's very clear, and its answer exactly right where my confusion is. Thank you so much, Dr. Irfan. And then I already see another question here from Sasha. First of all, thank you for your great presentation, sir. I have a question for Mr. Nan. So, as robots become more autonomous and integrated into workflows, may I know what cybersecurity risk should organization anticipate, and how can they mitigate them?
Yeah, thanks for the questions. The way I see it is, even those how despite how much advanced that we are evolving in technology, the cybersecurity risk is always there. So those usually when we talk about how we protect our value or protect our business, is there are two sides of that. The first is on the technical control, which means that we apply all of the technical solution to protect our environment from unauthorized access, prevent the network attacks, and so on and so forth. So we have the solution from IT or some technical department to implement it already. But the second part is, to me, is more important, is how we raise the awareness and educate our people, especially our college working in those organizations, or for example the worker in the factory as well, to be equipped with the cybersecurity skill. Okay? To me, it's one of the challenge nowadays, that somehow the tendency people will put less focus on the cybersecurity risk, but in reality it should be a lifetime skill. Right? You also understand those risks, and even you apply for your personal aspect as well, not just only for the work environment. I think that the robotic security should be put into the bucket that we have IT, OT, and AI cybersecurity strategy already. And one of the aspects that usually I have been asked and working deeply right now on the ethical AI. Right? So we try to make sure that we avoid AI to make some bias, some hallucination, and those things really to turn out into the real benefit for organization. Again, to sum up with that, the way how to mitigate the cybersecurity risk, I think should put a lot of efforts to working on the education and raising the skill set of the people across all level of organization, and even in university or in the student time, they should understand and learn about those concepts of fundamental of cybersecurity as well. Thanks for the question once again.
Okay, thank you so much, Dr. Nan, for your answer. Sasha, I hope that answered your curiosity. But before we move to another person who asked, Sasha actually sent a question for Dr. Ivan. So we're going back to Dr. Ivan again. Dr. Ivan, I'd like to know, how does cyber's physical system enable effective collaboration between humans and robots in Industry 4.0 environments? Thank you, Sir.
I think that should be the question for Professor Nan because he's the expert in the field. But simply saying, Professor Nan is from the practical side, I guess, much more. He's both actually. I'm actually much more from the academic side, but I think Professor Nan already explained a lot. So we need to understand the benefit of combining those two. Starting from the traditional, moving to automation, sometimes it it becomes a journey somehow, right? If eventually we can make everything automated, that will be great. But also, Professor Nan have already mentioned that some parts it will not be great if we change it completely to the machine. But because we need some decisions from the expert, which is very, very difficult to model. So I think we need to understand those benefits first, which part we need to maintain in the somehow based on the people judgment, which part we should go on the digital side. So when we talk about cyber physical system, digital twin as well, then we need to have I always talk to my students, we need to have a big dream first, eventually what you want to make, and then let's go slowly but sure, changing things, anywhere we need it. I think that's some additional answer.
Okay, Sasha, I hope that answer. Perhaps Mr. Nan want to add the answer, since Dr. Ivan is more on academic and you're on practical side. The question is, how does cyber physical system enable effective collaboration between humans and robots in Industry 4.0 environments?
Yeah, I think it's varies from industry to industry and depends on the architect and the infrastructures of any kind of business. When they establish the enterprise ecosystem to design what works best for the business that they're operating in. I think that there's no one-size-fits-all answer to that. It really depends on the business priorities. Right? They want to save certain of costs in terms of the operating by applying technology. So it could be one of priority that they invest into robotic and automation. Vice versa, there's the business, their car business that they just want to working on the top line, so they don't want to reduce any cost at the moment. So I think that to me is the question. We should work together at organization level, and before that the support function like for example IT or technical function can work on the answer based on the business ambition.
Okay, thank you so much, Dr. Nan, for the additional answer. Sasha, I hope that enrich your perspectives. And let's move to the next question. This is from Shafira for Dr. Parinda. It's a very good question. I like it so much. So I would like to ask a question referring to your material. How do you envision the next generation of engineers and technicians contributing to sustainable industrial development in the region?
Okay, that's a very good question. I believe that the next generation of the engineer or the technician will play essential in the advanced sustainable industrial development for our region in EAC Thailand. We focusing about the future engineer, not only strong competency, but in the automation, intelligent control, or digital technology, but we also focusing about the resource efficient, environmental sustainable. So in my field of vocational education and competency-based learning, we aim to prepare students become overcome about the problem solving and the innovator and capable to apply technology to improve industrial processes and support the local community and sustainable development goal. Yes, by working with the industry partner or the community enterprise stakeholder. Yes, thank you.
Okay, thank you so much, Dr. Palinda. I think this question, the next question from Putra is quite related to previous question. So this person wanted to ask how important it is to master a fundamental calculus and physics to be implemented in automation or robotics industrial application.
Okay, I think that every subject in the about the engineering have to relate it to and fundamental to the calculated. So the first of all, calculate about the calculate is the fundamental of the understanding is dynamic system, and such as differentiation, integration, or something creating model. And second, we think about that physics provide the foundation of the understanding machine or something at the real world situation. And however, it is important to note that have students not only to need theoretical knowledge, but they have to also learn how to apply this principle in the practical engineering context as well. So in summary, calculus and physics from the intelligent foundation of automation and robotics is enable to engineer and technical to design about the something, the model and the machine, analyze and improve intelligent industrial system. Thank you.
Okay, thank you so much, Dr. Panda, for your answer. I believe there's still a lot of questions, but we need to move forward in a second session. So I think I would like to, maybe if the speaker, the experts want to answer through the chat box, I would be appreciate it so much. Thank you. Okay, so let's move to the next session, which is the session 2. Please wait for Okay, so the next speaker will be Prof. Yuli Erdani and Dr. Tinagaran Perumal. So, but I just received sad news from Dr. Tinagaran since he has another meeting. So, Dr. Yuli, are you here with me? Perhaps could we switch the order, Prof. Yuli? So, Dr. Tinagaran,
Okay.
would that be okay?
Sorry.
Okay, so I'm truly sorry for this inconvenience, but I just received news from Dr. Tinagaran. So he has another important stuff that he needs to do at 15:30. But is it okay if we switch the order? So Dr.
And it's
Tinagaran
no
can
problem.
present.
Okay. Okay, it's no
Thank you so
problem.
much, Dr. Yuli.
Okay, no problem.
Really
Okay.
sorry for the inconvenience. Okay, so let's move to the next session. which is the second session, as you guys can see here in your screen. Our next speaker will be Professor Dr. Insinyur Yadi Ardhani from Polytechnic Manufaktur Bandung, Indonesia, and Dr. Tinagaran Perumal from University Putra Malaysia, Malaysia. But as we already switched the order, the fourth speaker will be Dr. Tinagaran Perumal from University Putra Malaysia. He will be presenting about artificial intelligence of things, or AIoT, powering the next wave of smart manufacturing. Dr. Tinagaran, are you here with me?
Yes, I'm here. Thank you.
Please, you can share your screen, and time and screen is yours.
Okay. Just hold on, I'm sharing my screen now.
Yes, can you share your screen, or do you need my assistance?
Yes, okay.
Okay, guys, please wait.
1 minute, yeah. Okay. I hope you can see my screen. Yeah.
Yes, it is very clear. Okay.
All right.
Dr.
Thank you.
Tinagaran, time and screen is yours.
Thank you. Thank you very much, Rita. Right. Okay. It's a pleasure to be on board today, right, for the international expert sharing. Okay. In the next couple of minutes, I'm just going to take the audience to share about the AIoT, artificial intelligence of things. How does it going to powering the next wave of smart manufacturing, especially in the Malaysian and Asian context, right? So if you look at the Malaysian AIoT solution cases, it's very clear that many of the substantial focus is actually in the manufacturing sector, and which is stimulated by the semicon industries. And a lot of works are going on, right, especially on how AIoT could actually influence the manufacturing sector in Malaysia, right? And looking at the various facets that AIoT could offer, ranging from the memories, algorithms, fabrications, right? Manufacturing wearable sensors, optical sensors, electrical sensors, which are very much centering on the semicon industry itself, right? So this was actually also contributed by the Malaysia as well as Asia's AIoT readiness, okay, which is around 90%. And if you look at in AIoT acceptance, manufacturing takes the largest portion, right? 18% would be from the manufacturing side, while 17% from the finance and the rest from the different verticals, right? And this is something that how the tech landscape is actually moving on. And what is happening now is actually Asian countries, right, are looking forward becoming a hub with the major manufacturing ecosystems, right? At the same time, looking at the possibilities of having deep talent pool. And the very important part would be the multilingual, because we are going very globally oriented, right? And in Malaysian case, there will be a lot of robust supply chains in various states, right? And there are also investors incentives, right? Something like from the government's agencies like MIDAR, MDAC, who actually provides business incentives for all the investors, right? And of course, this will actually gives us very stable IP framework, intellectual property framework, and as well as offering some competitive operating cost, right? And the China One policies also highly influence the innovation base to the Asian market. So what is happening now is that due to the significant growth in the semicon industry, right, Malaysia is also expanding its capabilities in design and manufacturing. And to be precise, the deployment of AIoT is now focused on what we call as neuromorphic. So neuromorphic is actually, it's a field by itself. We call it neuromorphic computing, a field that applies the principle of neuroscience to the computing systems to mimic the brain's function and structure. And the advantage of having neuromorphic AIoT in the manufacturing, because it's actually cascades all the important verticals like computationals, AI, augmented virtual reality, wearables, and these kind of productions of neuromorphic chips have high potential to outpace the traditional way of doing, computing in different sectors. And we also expect that when we have neuromorphic AIoT, this could be emerge as a very much promising solutions in verticals or domains like AI, healthcare, as well as robotics in manufacturing. So the Malaysian roadmap clearly stipulated that the non-exhaustive list of incentives for many Asian partners, right, who actually would like to invest into the manufacturing sector, especially in using AI and AIoT. So for instance, tax incentives, inclusive manufacturing, incentives for R&D, incentives for automation and digitalizations, incentives for acquiring intellectual property, right, and even for some of the economic corridor incentives, right? So there's a long list on that. So Malaysian ecosystem will definitely benefit, right, from the multinational corporations establishing their AI R&D hubs here in the Asian sectors. So other possible partnerships could be something like private-public partnerships, where universities plays a very important role. We saw a lot of universities from Thailand, Singapore, Indonesia, looking across collaborations, right, underpinned by domestic innovations. And this is a way forward, because when you have like incubators across the region, that would actually help to create more robust ecosystems for product innovations, right? So this innovations or investment opportunities could be in the software, platform, even data. One special thing about AIoT is that they have a complete spectrum of edge AI frameworks, which is done for the manufacturing sector. So they provide also vertical apps for manufacturing, agrotech, energies, cities, healthcare, right? So this is based on the standards, right, of course. So why Malaysia is for overseas investors? Because we have very much close proximity and also the cultural affinity. This could boost the similar supply chain bridges. China plus one diversification with Asian access, and of course, strong universities and R&D partners like EPM, for instance, where I come from. And this could also provide attractive incentives and collaborative test beds with agencies. So what happens is that many universities now are looking for matching fund, because when there are lack of local incentives or local grants, universities are moving forward, to establish cross collaboration matching fund in order to foster some frameworks on the something like joint venture with local champions, or even contract manufacturing, ramps and so on, right? So co-R&D with universities for AGI and cyber physical systems are some of the example models. So this could be some of the possible potential, right? So how long it will take for us to do this, right? So typically it will take 12 to 8 months roadmap to scale. Of course, first you're discovering your cross collaboration partners, partner selection, even data readiness, and then the phase 2 co-development, proof of concept, looking at some measurable KPIs, and even providing certifications, right? And then the final stage would be the manufacturing localization, which is the very important aspects, and also some of the financing structures, right? So these are some of the AIoT products and ongoing research, which has some close relationship with the manufacturing and the other sectors. So for instance, we have like AIoT-enabled aquaculture water quality monitoring systems. This is more likely to automate and optimize aquaculture water quality management. So you have AI GRU-based predictive model that actually analyzes the sensor data to forecast the potential water quality. So as we have different nations who have different classifications, right? So in Malaysia, we follow the national water quality standards for compliance. So likewise, in Thailand and Indonesia, we could actually replicate the similar scenario. And then we have a Gen AI powered smart home energy management systems, right? This is something like to an IoT solutions to design optimize power consumptions through automation and real-time insights. Gen AI powered air quality monitoring systems, right? Also sub projects from this. Then we have AIoT-based explainable activity recognition. So these are more on the premises, on the buildings, where we use AIoT to study the behavior, the activity behavior of the populations. So this kind of work would be very useful for large populated premises, large populated sectors. All right, even including manufacturing when you have many facets. So we could use AIoT to understand the activity and behavior in order to come up with behavior patterns that could tailor to the specific industry. So some other use cases like healthcare and ambient intelligence are quite common in the AIoT. So in Malaysia, they are potentially trying to unlock over US 113 billions, right? And this is part of the NIMP plan, New Industrial Master Plan 2030, and other economic blueprints. So just to share, this is a book, all right, that actually also discusses about one of the manufacturing sectors domain, especially how do we apply AIoT and smart sensing, right? Okay, so thanks. That's from a brief expert sharing from my side, right? I'll be happy to take up one or two questions, and thank you to Prof for allowing for the switch of the time, and thank you, Ribda, for arranging that. Thank you.
Okay, thank you so much, Dr. Tinagaran. I hope the presentation could give more insights to all of you, our dearest participants. So without, sorry, Dr. Tinagaran, I will stop your screen share, and we will move to the next session, which is presentation from Professor Dr. In Yuliadi Erdani from Politeknik Manufaktur Bandung, Indonesia. So, Prof. Yuli, are you ready? Okay, I have already
Thank you
seen
very
him
much.
here.
Ready,
Okay,
okay.
he will be.
Okay.
Okay, so today he will be discussing about digital twin-driven intelligent control for equipment manufacturing optimization. Prof. Yuli, the time and screens is yours. You have 15 minutes for the presentation. Thank you.
Okay, thank you very much. Okay, everybody can see my slide?
Yes, it's very clear.
Okay, just a minute. Okay, now let's try. Okay, it is my pleasure to me to speak in front of you. Everybody can hear, yeah? So good morning, good afternoon, everybody. Today I will present our study entitled Digital Twin-Driven Intelligent Control for Equipment Manufacturing Optimization. So this research investigates how digital twin technology integrated with predictive analytic and intelligent control strategy enhance the performance, reliability, and efficiency of modern manufacturing system. So this is my agenda to explain about our work. And as we know that rapid advancement of Industry 4.0 has accelerated the adoption of digital twin technology in manufacturing system. Digital twin provide a virtual representation of physical asset, enabling real-time monitoring, predictive analytic, and adaptive control, which contribute to improve operational efficiency and system reliability. So if we see this, there are some related work concerned with digital twin. And if we see the architecture of digital twin, we have 6 components of digital twin system. First of all is a physical manufacturing equipment and sensor, data acquisition system, communication layer, digital twin model, predictive analytic, and intelligent control module. So there is, if we see that this is a component that I've already talked about it. So there is a physical manufacturing equipment and data acquisition system and digital twin model. And in the right side, we see that there is some very powerful module, predictive analytic module, and intelligent control module. Just a minute. Okay, now we talk about physical manufacturing equipment. The physical layer include manufacturing equipment such as CNC machine, can be CNC machine or any other or any machine, yeah, other machine. So and also robotic manipulator, conveyor, and so on. So we can have arbitrary machine can be put in the system. And industrial sensors such as vibration, temperature, current, and pressure continuously monitor operation condition as computing device perform preliminary data processing before transmitting the information for the further analysis. After that, we must have a so-called communication layer. The communication layer ensures reliable and low latency data transmission using industrial protocol such as MQTT or industrial Ethernet, yeah, or OPC UA. Now come to the digital twin model. The digital twin model integrates physical-based dynamic model, data-driven machine learning model, and set estimation technique. Real-time synchronization between the physical system and the digital module is achieved using set observer and Kalman filtering, which improve model accuracy and control performance. We need also a so-called digital twin synchronization. And other very important module is a predictive analytics module. I think this is I can say this is something new in this decade because before in the last 10 years we didn't speak about this module, but now since 5 years there's some researcher talk about predictive analytics module. Yeah, this is that module perform fault, for example, fault detection, anomaly detection, and remaining useful life estimation. Machine learning approach, including LSTM network and Bayesian inference, are commonly used to support predictive maintenance in smart manufacturing environment. And other important module is a so-called intelligent control. In the control layer, also there is module predictive control MPC is applied to generate optimal control input while satisfying operational constraint. The digital twin provide predictive state that are utilized by the MPC optimization process to improve control decision. Of course, if we implement everything to the system, so there is some requirement. For example, system dynamic model, we have to regard an asset degradation model, cost function error, parameter update, model predictive control, or it's called MPC, and multi-objective optimization. If we see that concerning the mathematical modeling and computer science, online learning enhanced predictive capability. There is some paper discuss about that, and other paper discuss that the MPC ensures consent handling and optimal dynamic response. Other paper also discuss about the remaining useful life. So this is a calculation of RUL prediction, support predictive maintenance scheduling. And other paper talk about multi-objective manufacturing optimization enable real-time trade-off among quality, energy efficiency, and productivity. So now come to the implementation. So to validate the proposed framework, a simulation-based smart manufacturing was developed. The implementation integrate nonlinear plan, dynamic real-time sensing, digital twin synchronization, predictive analytics, and MPC-based adaptive control. We come to the performance evaluation. The system performance was evaluated using several metrics, including equipment utilization rate, production throughput, prediction error, tracking error, and downtime reduction. Simulation results indicate improved stability, enhanced fault detection capability, reduced downtime through predictive maintenance, and increased equipment utilization. And also, if we see the comparative, just a minute. Okay, now come to the comparative analysis. Compared with conventional control approach, the proposed framework demonstrates faster disturbance rejection, higher robustness, improved prediction accuracy, and more effective maintenance scheduling. Now we come to the discussion of our study. So digital twin driven control enhance adaptability and operational efficiency through predictive decision making. There is also a challenge include computational complexity, data security, model scalability. It is also the thing that we can discuss in the future. And the future system will integrate distributed data twin, edge intelligence, and autonomous decision making. Now come to the conclusion that the study present a digital twin-driven intelligent control framework that integrates predictive modeling, synchronization, MPC, and multi-objective optimization. So if the framework that I have to already state that framework improves system stability, reduce downtime, enhance predictive maintenance, increase manufacturing efficiency. Future work will focus on reinforcement learning-based control and distributed data twin architecture for Industry 5.0. I think I have a small presentation today. I hope everybody understand what I present. Thank you very much for listening to me. Thank you.
Okay, thank you so much, Dr. Yuli, for your presentation. It's a very insightful question, and I have already seen several questions here sent by the participants. So before, let me share screen. Okay. Okay, so I have see many questions. This is sent for Dr. Tinanggaran Peruma, but guys, please also send, if you guys have any question for Prof. Yuli, please feel free to send it and I will read it. Okay, so this question is from Livi. Dr. Tinanggaran, could you perhaps answer the questions now? Okay, so I think Dr. Tinanggaran is couldn't now as he has another meeting to attend, but I would like to ask for Prof. Yuli. Okay, wait for a second.
Yes, please.
Okay, this is from Johanna. How does the intelligent control module balance multiple objectives such as product quality, energy efficiency, and productivity in real time?
Sorry, this is a little bit noise here.
Okay.
Can you repeat, please?
Okay, this is the question is from she asked about how does the intelligent control module balance multiple objectives such as product quality, energy efficiency, and productivity in real time?
Okay, this is about physics. Yeah, I have said that I think there's some intelligent system. Just a minute, I have to see. we have to see to the mathematical model because the system also first can evaluate the condition of system, and then after that they learn about what the system should do, and then they calculate uh, which effort and throughput, and they calculate and then can bring the optimal result for the system. So that's why the fault detection can be calculated and can be determined more accurately. Yeah.
Yeah, okay. Okay, Johanna, I hope that
Okay.
answered your questions. I would like to call again for Dr. Tinagaran. Could you join our Q&A? Oh, he didn't respond. Okay, so Prof, my question, it's for me. So I would like to ask about what steps should the manufacturers take if they want to start adopting digital twin-driven intelligent control systems? The question is actually from myself. So, what steps does the manufacturers should take if they want to start adopting digital twin-driven intelligent control systems? Yeah, this is Shafira already retyped it for me. Thank you so much, Shafira. Shafiri? Is it clear enough, the question? Okay, please wait for Professor Yuli to prepare the answer. Okay, while waiting for Professor.
No, should I answer now?
Yes, please. Prof. Yuli,
Okay.
please answer now.
This is a question from Jess Melodia. Yeah? Okay. But how does digital twin improve equipment performance and decision making? So I try to answer. So the key difference can be explained in several aspects. There is a real-time dynamic representation, predictive capability, simulation, say, adaptive and control, and so on. I think while traditional monitoring system mainly provide visibility into equipment status, a digital twin offer a predictive simulation driven and decision support framework. So this is the advantage of digital twin. Yeah. Okay. Hopefully it is clear. Yeah.
Yeah, thank you so much, Prof. Yuli. Have that answer, that already answered actually. So maybe we can do a last question for you, Prof. Yuli, since Dr. Tinagaran couldn't join us. This question is from Sasha. She asked about I kinda curious of how do machine learning techniques such as LSTM contribute to more accurate fault detection and remaining useful life prediction. Thank you.
I think I have answered before, or this is not clear, hopefully. So, okay, I try to, okay, yes. Perhaps I try to answer first to the last question. I would like to ask regarding step by step, should manufacturing take if they want to start adopting digital twin? Yeah, this is I have already prepared. So this is first of all, we must assess digital readiness of our system and define objective. Second thing is establish robust data acquisition infrastructure, and then we can start to develop the digital twin model. After that, integrate analytic and predictive capability of the system and connect the digital twin to the control system. start with pilot project and scale gradually as a small pilot project first, yeah. After that, we can develop organizational capability. So successful adoption of digital twin-driven incident control system requires not only technological implementation, but also strategic combination of infrastructure, development, modeling, analytic integration, pilot experimentation, and workforce capability building. This step enable manufacturing to gradually transition towards smarter and more adaptive production system. Okay,
Thank you so
hopefully
much.
this is hopefully this is I can answer the question.
Okay.
And next question, yeah, right? One question again concerning
Okay.
to LSTM,
Yeah,
right?
I'll ask them.
Okay, okay, I try to answer it. So, machine learning technique, particularly LSTM long short-term memory network, play an important role in improving the accuracy of fault detection and remaining useful life error prediction in modern data system. Their contribution mainly come from their ability to analyze time series data and capture long-term dependency in equipment behavior, like modeling temporal pattern in sensor data, early and more reliable fault detection, improve remaining useful life prediction, integration with digital twin, and so on. So hopefully I can answer the question. Okay.
Okay, thank you so much, Prof. Yuli, for your answer. Sadly, this Q&A session, the second session of Q&A, we only have Prof. Yuli, but I believe all the participants here are also curious to Dr. Tinagaran, but due to he has another job that he has to do, he couldn't join. But yeah. Okay, so I think that will wrap up our Q&A session for today. Perhaps, Prof. Yuli, you want to speak a few words for a closing statement, maybe, or not? Okay, I think no. Okay, so we will after this we will have a group photo session. So for all the participants, I would like to call all the participants to open your camera. After this, my colleague will send send a visual background that you need to use. Wait, let me share this. Okay, please use the virtual background that I already sent in the chat box during photo session. And while waiting for the participants, for everyone to open their camera and set the virtual background, I would like to inform that actually our webinar today will be uploaded in our Instagram at Pasita Education. And here we will update our upcoming events, our programs, and all activities. So please follow. And also we have our website, which will be also sent by our college. Okay, I think I have already seen the participants opening the camera. Perhaps we'll wait for 30 seconds. And on behalf of the organizers, I would like to share our deepest gratitude to all of you here who joined, especially all the experts, for all your insightful presentation, for all the answers that you give to the participants. And we're truly sorry, apologize if any short mistake were you feel during all the event, throughout the event preparation and during the event day today. So yeah, okay. I hope to see you again for all our speakers, and I hope to see you again, our participants, in our upcoming events. Okay, I have already seen many people open your camera. Okay, let's do the photo session. Wait for one. Okay, I will count until 3, and then please, okay, please smile. 1, 2, 3. 1, 2, 3. Next slide. Next slide. 1, 2, 3. Okay, thank you so much, everyone. After this, my partner will send the attendance link. Please fill it and please check in your email because it will directly send to your email. If you don't, please check your spam or your junk folder. You will find your certificate there. And for all the speakers, once again, thank you so much for your time. After this, I will send all the screenshots and as well as the certificate to you. Thank you. See
Thank
you
you
on
very
our
much.
next